Okay, so we've talked about partitioning clustering, where each item goes into its own segment or cluster. Segment in a business sense, cluster when it comes to the computational technique. Now we're going to do something a little different, which is called hierarchical clustering. So let's just imagine that we have Ford and Chrysler are pretty close together. And we have maybe Lexus and BMW a little bit further apart. So what we do here is we decide, okay, each item, this is called agglomerative clustering. And each item starts off in its own cluster. We have 4 clusters. Now we merge the 2 closest items. So we have a new cluster. Now we calculate the distance between this guy and this guy and this guy. So now this is like a new cluster, and this guy is probably still further away than Lexus and BMW than they are to each other. So the next lot, we're going to merge like this. And then finally, we have 2 clusters. And these 2 clusters, well, we only have one way of making them one cluster. Whoa, we didn't want to do that. Let's just go back to 100%. Okay, I can just about fit it in there. This goes to one cluster here. And this is called the root. And these guys are called leaves. And, you know, we could actually cluster at any point here. So if we want like 2 clusters, we basically cut across here. And everything on this branch is in cluster 1. And everything on this branch is on cluster 2. Now, the important thing is how we actually join the items. And I'll talk a little bit about this in a minute. So once we join 2 items together, we have to work out how close they are to other items before we continue joining the clusters. And I'll give you an example of that in a second. Okay, so imagine that we've joined 2 items together. We're going to call these guys A and B. But they might actually be Ford and Chrysler. Now, each of these items has a distance to a third item C. And this guy is going to be 5 away. And this guy is going to be 3. Let's make B a little bit further away, just so that looks realistic. Now what happens is we go through our hierarchical clustering and we've merged, A and B into one single cluster. Now we need to know the distance between A and B. So let's call this merge cluster N. So for example, we want to know the distance between C and N. And we need to do this because, you know, at each stage of the algorithm, we kind of merge our 2 closest items and we kind of carry on until we have one item. So for this to work, the new cluster has to have a distance between it and every other object. So what we're going to do is we're going to have different ways of doing it. So we have complete linkage. And here D, C, comma N is basically the maximum of the two distances. So it's the maximum of C and A and C and B. So it's just, we've got two distances, 3 and 5, so it's going to be the maximum of 3 and 5, so it's going to be 5. And then we have single linkage. And guess what? It's going to be the minimum of D, C, comma A, and D, C, comma B. So it's going to be 3. And then we have average linkage. I think you know where this one's going. And it's just going to be the average. All over 2. So in this case, that's going to be 4. 3 plus 5 over 2. And there's lots of other ways of doing this. There's all sorts of methods. It's called rewards method, centroid clustering, but just worry about the 3 for the moment. And in practical terms, complete linkage gives you nice kind of almost round clusters. Single linkage has kind of almost, you know, almost very elongated clusters, but I'll show you now in R. So here we have our hierarchical clustering. So let's just, again, as per before, we have to first calculate our distance matrix. So that's our distance between all the items in the clusters. So each of the 6 items has a distance with the other 5 items. Then all we have to do is run the hclust and give the method single, complete, or average. Now, if you look at the help for hclust online or Google, you will actually find a load of additional methods behind that. So let's run all these 3. Now, what I drew when I drew those trees, that we call a dendrogram. So let's just see what the dendrogram is for the complete linkage. I give it a title, and I give it the labels, which again is the first column of the cars. And here we go. So this is a complete linkage. And you can see we have Ford and Jeep. The lowest is actually Lexus and Mercedes. Then we add infinity to this cluster. Then we have Ford and Jeep, BMW, Chrysler and Volvo. Then the Ford, Jeep, Chrysler and Volvo kind of merge almost into one family cluster. And eventually BMW and Porsche merge with our kind of upper mid-market luxury cluster with the sporty cluster. And then the kind of lower end of the market cluster merges with the higher end. And we have the root linkage. Let's just see the same for single linkage. And you'll see what I mean by it being a little bit more elongated. You can see we get these kind of items joining to each other together in chains a lot more. And then average linkage is somewhere between the two. And as I said, we can do the cut. So we basically will cut into, so here if we cut here, we cut into 1, 2, 3 clusters. And then we get each item, which cluster it's in. And we do exactly the same as before. We add it to our new cluster. For some reason I've forgotten to assign it to a variable. But we'll solve that. And then we plot it as so. So this is like the equivalent for hierarchical clustering. Now, why would I want to use k-means when hierarchical clustering has got partitioning clustering built in? Well, sometimes because it works with distance, it works kind of optimal distances. K-means may be a little bit more accurate, but it's sometimes down to personal preference. Okay, so that's this week. We started off with some broad intuition of segmentation. Then we went through the different methods to do visualization and segmentation together. Obviously, these are pretty small data sets to get you started, But what, used together, cluster analysis and visualization, are pretty important and powerful business tools. If you have a lot of variables and you want to show, how close items are to each other, either products or customers or maybe companies that you're auditing, then these techniques are pretty useful.